In this video, we will be talking about finite geometric series. This is a continuation of our chapter about sequences and series. In the past videos, we've talked about arithmetic sequences, arithmetic series, and from the recent video, before this, after, before this actually, we had geometric sequences. And now, we'll be tackling about finite geometric series. In general, we have two specific lessons for geometric series. We have finite, and the other, which is going to be in the next video, will be about infinite. So please take note that there are various solutions, various formulas for arithmetic sequence, arithmetic series, geometric sequence, and finite geometric series and infinite geometric series. So I hope this doesn't confuse you for now, because we'll be tackling for the most part all about finite geometric series. So let's start with number one. The instructions say evaluate the related series of each sequence. When we mean by evaluate, basically we're called to find the S sub n of the given sequence. So for example, for number one, the question is, how do we find n? Well, the answer is pretty simple. We'll just count how many terms, and the number of terms that we get is our n. So for number one, we have 4 terms, so n is equal to 4. Therefore, what we're trying to find here is S sub 4. I hope you understand this right now so far. Let's move on. By the way, for infinite geometric series, we'll be using the formula S sub n is equivalent to a sub 1 times the quantity 1 minus r raised to n divided by 1 minus r. Please keep this in mind, because the formula is going to be used for literally every problem here. But there's a big disclaimer before you proceed to the video. We won't be answering numbers 19 to numbers 26. So from here to here, we won't be answering it, because I cannot teach this part yet, because these problems involve what we call logarithmic functions, which isn't introduced in our school yet. As for now, maybe we'll be learning this topic in the future, but as for now, we're going to focus on these on the parts of numbers 1 to 18. All right, let's get back to number 1. So what we're trying to find is S sub 4. Again, our formula, we'll be basing our solution there. So our a sub 1 is equivalent to 2, this one. Our common ratio, from the previous video, I've taught how we could find a common ratio. Basically, a typical a sub 2 divided by a sub 1. For example, 12 divided by 2, this is a sub 2, this is a sub 1. Or probably, if you want a higher difficulty, 432 divided by 72, a sub 4 divided by a sub 3. Well, you still get the same answer. 12 divided by 2, 432 divided by 72 is 6. Our common ratio is 6. Now, let's move on. S sub 4 is equivalent to a sub 1 times the quantity 1 minus r, which is 6. By the way, it's better to place a parenthesis in between with it for the common ratio, so that the calculator would see it not in a different answer. You should be careful in terms of that, because one way or another, you might not notice that the calculator is giving a different answer just because you missed out with the parentheses. So yeah, that's a reminder, so that you won't be falling into the footsteps of my mistakes in the past. Let's continue. So our raised to n our n quantity is 4, this one. So, divided by 1 minus r. Our r is 6. Alright. In this case, let's place these numbers and terms in the calculator. And our answer would be 518. In terms of calculator, like I said before, it's better to use a scientific calculator rather than a basic. For many reasons, many strong reasons. Alright, for number 2, let's figure out our a sub 1 is negative 1. Our common ratio is negative 5. Why is it negative 5? Well, 125 divided by negative 25 is negative 5. 5 divided by negative 1 is still negative 5. That's simple. Alright, how many terms? So 1, 2, 3, 4. What we're trying to find is s sub 4. Because n is equal to 4, so s sub 4. Evaluate s sub 4, again, base it into according to the formula. So our a sub 1 is equal to negative 1 times the quantity 1 minus r raised to n divided by 1 minus r. Now, let's place this in the calculator. And our answer would be 104. Let's proceed to number 3. A sub 1 is equal to negative 2. R is equal to negative 3. Let's proceed. Our n is equivalent to 1, 2, 3, 4, 5. N is equal to 5. Therefore, what we're trying to find is s sub 5. S sub 5 is equal to negative a sub 1, a sub 1, which is negative 2, times the quantity 1 minus r raised to our n, which is 5. Yeah, it's a minus. Divided by 1 minus r. So, our s sub 5 is then equivalent to negative 122. For now, we're doing the long cut, but for the following problems, such as this, I'll introduce this better later. Let's focus on our current problem first. Alright, we get negative 122 there, given this solution. Alright, let's move to number 4. Number 4, a sub 1 is equal to negative 2. R is equivalent to 6. Alright, n is equivalent to 1, 2, 3, 4, 5 terms. So we're going to find s sub 5. Wrong color. S sub 5. S sub 5 is equivalent to negative 2, which is a sub 1, times the quantity 1 minus r raised to n divided by 1 minus r. Alright, s sub 5, given this in the calculator, our answer would be negative 3,110. Alright, we're finished with part 1. Let's move to part 2. Evaluate each geometric series described. So again, I made a foreshadow a while ago about this lesson. First of all, I'll be teaching you the long cut, and as soon as you understand how things work, how the solution actually works, we can move on to the shortcut, which I just recently discovered earlier, a few minutes ago, before even producing this video. The technique, I'm not sure, this isn't proven yet, but I think it does the job. It still gets the right answer. So yeah. Alright, let's back to the topic. The traditional technique is, we'll place arrows here. We'll be making good use of the given here, and we'll be finding a sub n and a sub 1. A sub n, the n depends on the number here. So here we have 7, so our a sub n is equivalent to a sub 7. Let's solve. Substitute the values. 4 raised to 7 minus 1 and 4 raised to 1 minus 1. Alright, so 4 raised to 7 minus 1, our answer is 4096. So that is our a sub 7. Now, 4 raised to 0, we have 1. 1 is equivalent to a sub 1. Alright, let's find r, our common ratio. In order to find the common ratio, this is the traditional technique, the long cut. Basically, we'll be making good use of the geometric sequences formula, geom sequence, which is basically what we learned in the past video. A sub n is equivalent to a sub 1 r raised to n minus 1. I'll give you a visualization. So a sub 7 is our a sub 1 again, is equivalent to a sub 1 r. That's what we're trying to find, raised to 7 minus 1, n minus 1. So we have to replace the values. 4096 is equivalent to 1 r raised to 6. Divide both sides by 1. Nothing changes. It's still 4096 on the left side of the equation. Let's put things this way. Nothing really changes that much. Okay. We'll place a how do you say this? A root this way. I'm not sure how to describe it, but by the looks of it, I hope you can see where I'm getting through. Place this in the calculator for the 96, and our r is equivalent to 4. So I hope you can see the analysis of how we apply the geometric sequence for finding the common ratio, the traditional way. Now, let's move to finding, sorry for that ringtone, it was an accident, it was never expected. We'll wait. Alright, I'm so sorry for that. Okay, let's go back to our lesson. S sub n, how do we know the value of n? Well, just a while ago, n is equal to 7. We find our n value. It depends on the value that's displayed on the top of the sigma symbol. By the way, you might be wondering what this symbol is. Well, it's the sigma symbol. It's a letter of the Greek alphabet that for some reason is part of this lesson. I'm not really sure about how the sigma symbol is related to this topic of pre-calculus about finite geometric series, but surely other videos would explain it better. But for now, we'll be focusing on how to solve problems that are linked to these. So now that we know what n is, so what we're trying to find after all is s sub 7. S sub 7 is equivalent to, we're going to use the formula now, this usual formula, the commonplace one. A sub 1 times the quantity n, 1 minus r, our r is 4, raised to n divided by 1 minus r. Now, in this case, we place this in the calculator, and our, I'm sorry, I forgot to replace the value of a sub 1. There you go. S sub 7 is equivalent to 5,461. Alright, let's move to number 6. For number 6, we'll still be doing the traditional way. I'll introduce the technique by the next number. So let's find a sub n. A sub n right now is going to be not really that useful or not really that important to solving our final answer, but for safekeeping, I think it's better to show it to you right now, because for using the shortcut technique, we won't be finding a sub n anymore, because this is not going to be useful, or it's not going to be used to find the final answer. But instead, what's going to be important is finding a sub 1 and our common ratio. Anyways, this is our last demonstration of the traditional technique. So negative 6 raised to 1 minus 1. Now, negative 6 raised to 8 minus 1, basically our answer is negative 279,936. And our a sub 1 is 1. How is it 1? Well, any number, literally any number, whether it's negative or positive, if it's raised to 0, it's still 1. Whatever happens, it's still 1. This is a law of exponent. I think it's in my very first video, a bond paper lecture regarding the laws of exponents. I hope you can see that video so you could be trained with the lesson, because as said, what we've learned in the previous high school years would be really important so that we could understand the lessons now. This is a grade 10 lesson, so yeah. Back to the topic. Let's find our common ratio. Again, geometric series formula, forgot this, a sub 8. A sub n is equivalent to a sub 1 r raised to 8 minus 1. A sub 8 is negative 279,936. Our a sub 1 is 1 r raised to 7. Divide both sides by 1, nothing changes. The nature of multiplication, division is like that. R raised to 7 is equivalent to negative 279,936. Root both sides with 7. I'm not sure if that's how you say it, but I think you're getting it with what I'm writing, hopefully. So root negative 279,936. Our r is equivalent to negative 6. Now, let's find s sub n. What is our n? N is equivalent to 8, the number above the sigma sign or symbol. So let's find s sub 8. S sub 8 is equivalent to a sub 1 times the quantity 1 minus r raised to 8 divided by 1 minus r. So basically s sub 8, place this entire thing in the calculator, and our answer will be negative 239,945. Alright, let's move to number 7. Now we'll be using the shortcut way. This is not according to my solutions before making this video, but I think I have to freestyle. We won't be using the traditional anymore. Basically, if we're given this kind of problem, how do we find r? Well, with any number that's here, that's labeled here, any number like literally this, the number at the right side. If there's none at the right side, literally the number itself. So numbers like these don't have, not that. Numbers like these don't have another number, so we'll assume that these numbers are already r. So that's it. Let's move to our initial problem. So in this case, our r is 2, such that if there's no left term or left quantity like this, we see that this is a left quantity times something. I think as you can see, it resembles the formula of geometric sequences. So a sub 1 r raised to n minus 1. So here n minus 1 and a sub 1 r. I hope you're getting the pattern, because this is going to be really vital, really vital for the shortcut technique. So r is equivalent to 2, there you go. And how do we know a sub 1? Well, the answer is already there too. Either you do it the traditional way, just copy paste the entire formula, 2 raised to 1 minus 1, 2 raised to 0, 1 is equivalent to a sub 1. Well, by the looks of it, you can see that any number, how do I say this? 2 is still equivalent to 2 times 1. right? So in this case, 2 is equal to 1 times 2. Actually, they're literally the same. So let's just imagine that this is what is happening in this problem right now. So therefore, a sub 1 is equivalent to 1. That is our technique, our shortcut. Now, we know these two values already. Let's find s sub n such that n is equivalent to 9. So s sub 9. S sub 9. So I don't think there's any other shortcut here, but we still maintain that kind of substitution method. So a sub 1 times the quantity 1 minus r raised to 9 divided by 1 minus r. S sub 9 then is equivalent to 511. So that is our shortcut technique. Let's move to number 8. So we're given this kind of problem. So we know the drill. But in this case, we have negative 2 written this way. It's not in parentheses, so that means we could also suggest that negative 1 times 2, right? They're similar. I think they're the same, but it isn't exactly showed that way. So yeah, I think that's how things look like in this problem. And therefore, we can conclude that r is equivalent to 2. This is 2. So again, resemble the formula a sub 1 r raised to n minus 1. This is in this problem, we have m, but m is still equivalent to n. Don't be deceived about it. Don't be confused. And our a sub 1 is equivalent to 2. So here. I'm sorry. A sub 1 is equivalent to negative 1. There you go. Alright. Enough visualization. Let's move to substitution. What we're trying to find is a sub 9. Let's cut it now. Let's make things fast. S sub 9 is equivalent to a sub 1 times the quantity 1 minus r raised to n divided by 1 minus r. Now, given this, we place this in the calculator and our answer is negative 511. The answer is quite a coincidence. Both 511, but the difference is their operation sign. This is negative, this is positive. Well, in fairness, the given are different. Now, let's move to number 9. Alright, this time we have 2 numbers. So it's a lot easier to conclude that r is equal to negative 2 and our a sub 1 is equal to positive 2. So as if a sub 1 r raised to n minus 1, a sub 1 r raised to n minus 1, right? Alright, what we're trying to find is s sub 8 because n is equal to 8. S sub n, S sub 8. S sub 8 is equivalent to 2 times the quantity n minus, 1 minus r raised to 8, which is raised to n, divided by 1 minus r. Now, in that case, we have this in the calculator, and our answer would be negative 170. Let's move to number 10. So our a sub 1 is equivalent to 4, our r is equivalent to 3. Therefore, let's move now to finding the s sub n value, s sub 9 value actually. So s sub 9 is equal to a sub 1 times the quantity 1 minus r raised to n, which is 9, divided by 1 minus r. In that case, we bring this to our calculator again, and S sub 9 is equivalent to 39,364. It's very satisfying. Let's move to number 11. Alright, a sub 1 is equal to 4. Common ratio is equivalent to negative 3. Our n is equivalent to 10. So what we're trying to find is S sub 10. S sub 10 is equivalent to a sub 1 times the quantity 1 minus negative 3 raised to 10 divided by 1 minus negative 3, which is r. So place this in the calculator, and our answer will be negative 59,048. Very random, but this is actually correct. Trust me, every answer here is already checked before I even started this video. Everything is according to the answer key that's inscribed below this. So you can just check it here. For number 12, let's proceed. This is going to be a tricky question. I tried this before doing this video, and I had the wrong answer. So basically, cut it short. Let's find our a sub 1. Negative 2. Let's remove this. So we have a parentheses. Therefore, we can conclude that a is equal to 1 here. So 1 times negative 2 is still negative 2. In a parentheses, considering that. So let's just keep it there. Let's make sure if a sub 1 really is 1 by checking. 1 minus 1. So sorry. Negative 2 raised to 0 is 1. Literally. Law of exponent. Given that, let's find S sub 9 such that n is equal to 9. S sub 9 is equivalent to a sub 1 times the quantity 1 minus r raised to 9 divided by 1 minus r. Place this in the calculator. I'll turn on my calculator now. 1 times the quantity 1 minus negative 2 raised to 9 divided by 1 minus negative 2. Our answer is 171. There you go. Let's just check all of these. I have another copy beside me right now, and I can assure you that all of these are correct so far for page 1. 5,461, negative 239945, negative 511, positive 511, negative 170, positive 39,364, negative 59,048. Alright, let's move to number 13. We're given a different kind of problem, but our priorities remain the same. Let's identify a sub 1. It's 1, literally 1. I think that's not a coincidence. Yeah. Let's find our common ratio. Again, a typical a sub 2 divided by a typical a sub 1, or like 2 divided by 1 is still 2. So r is equal to 2. Alright, that case, how many terms? I mean, we don't really have to count it anymore. I mean, there's this kind of simple, so it's going to be inaccurate anyways. We know what it is already, so yeah. What we're trying to find therefore is S sub 6. S sub 6 is equivalent to a sub 1 times the quantity 1 minus r raised to 6 divided by 1 minus r. Now, for S sub 6, place this in the calculator. Give me a few seconds to compute. Our answer is 63. Positive 63. Alright, let's move to number 14. So we have a sub 1 is equivalent to 2. r is equivalent to negative 5. N is equal to 8. Alright. Let's find S sub 8. S sub 8 is equal to a sub 1 times the quantity 1 minus r raised to 8 divided by 1 minus r. And therefore, S of 8, calculate, our answer is negative 130,208. Let's move to number 15. The same strategy. A sub 1 is equivalent to 1. Not a coincidence compared to number 13. R is equivalent to negative 4, I suppose. Let's check. Negative 64 divided by 16. Yeah, R is equal to negative 4. Let's find S of 9 because N is 9. S of 9 is equal to 1 times the quantity 1 minus R raised to 9 divided by 1 minus R. S sub 9 is equal to 52,429. There you go. Alright, let's move to number 16. N is equal to 9. A sub 1 is equal to negative 2. R is equal to 3. Let's try. Let's make sure. Negative 54 divided by negative 18. Yeah, our answer is 3. So, S sub 9 is equivalent to negative 2 a sub 1 times the quantity 1 minus 3 raised to 9 divided by 1 minus R, 1 minus 3. S sub 9 is equal to negative 19,682. Alright, let's move to number 17. We're almost done. There's a few answers left, few solutions. A sub 1 is equal to 1. R is equal to negative 5. Let's check. Negative 125 divided by positive 25. Yes. R is equal to negative 5 indeed. Okay, let's solve for S sub 7. Because N is equal to 7. S sub 7 is equal to A sub 1 times the quantity 1 minus R raised to 7 divided by 1 minus R. S sub 7 therefore is equivalent to 13,021. Alright, let's move to number 18. N is equal to 9, A sub 1 is equal to negative 3, and our R is equal to 2. Alright, S sub 9 is equivalent to negative 3 times the quantity 1 minus R raised to 9 divided by 1 minus R. So S sub 9 is equivalent to, place the entire expression in the calculator, and our answer would be negative 1,533. Alright, we're finished. Let's just check. 63, correct. Negative 130,208. 52,429. Negative 19,682. 13,021. Negative 1,533. Correct. So we'll be tackling this hopefully in the future. Number is 19 to 26, but as for now, there aren't much plans for it. Let's go back to the very top of this sheet work, and I'll just show you my solutions. I admit not to be the best mathematician teacher out there, but with my best. I hope I am able to deliver to you at least some sort of help for your exam, for your upcoming exam regarding this topic. Usually this topic is introduced in 10th grade or third year high school. So yeah. I'm sorry. This is not third year, fourth year, grade 10. So yeah. This is the end of the video. I hope you're able to understand. Thank you for watching.